Okay, now today's lesson, if you could see here, is about building with waste plastic bottles in Honduras. It's going to be a different lesson today. And the objective of the lesson is to see if you can use mathematics to analyze a situation. So I'm going to show you a situation, and I want everyone here to be creative and find ways of using the mathematics that you know already. You've been doing mathematics from primary school up to this time. So I'm going to show you a PowerPoint slide, which I want everyone to think of what they are seeing, any problems that can come up, and then write all of them down. If you look at this picture, you could see how in some part of the world they are making use of the plastic bottles that you normally throw them away. They are making very good use of it. Looking at this, what I want you to do in pairs for 2 minutes is to make a list of all the things that you notice on this power slides. But whilst thinking of it, I want everyone to also note down any problems that occur to you.
That is how you represent the bottles of working, how to make a house. So how many bottles? That would be around, just in case if you have...
1 million bottles per...
No, millions.
To make a house.
Just to make a door, you would at least need about 50 small ones. So around for a house, it would need at least 1,000.
50,000.
1,000, like that, yeah.
Not 1,000, that's too small. 10,000.
10,000.
So we got a lot of bottles, like hundreds of them. I think they were making a wall or like a house. If the bottle wall fell down, it could hurt someone.
They use all the bottles that we recycle, so it wouldn't cost that much for them to make the houses from bottles, and it should be quite strong.
Because I stuff in the sand.
Now we're going to collect our ideas together, and then from there, we decide which ones will be very good for us to get some mass in it. So to start with, Macaulay, at the corner there, can you give us one thing that you noticed?
Noticed a window without glass.
Window without a glass. Ali?
Think, how many bottles do you need to make a school?
Okay, how many bottles do we need? James, give one example from your sheet, please.
How long did it take to make?
How long? Corina?
How much would it cost?
How much will it cost? Okay.
How can we get the precise measurements with all the different types of bottles you find?
Excellent. So that could be also be something that you found out, isn't it? Measurement of the bottle. So I'll write that here.
This isn't maths, why are we doing it?
James is saying that we are supposed to be doing maths. Is this mathematics? Who can answer this question? Becky?
You can use mathematics to actually work out how to build them, like how many bottles you're going to need and how much sand you're going to need.
Excellent.
And how much space it's going to take.
So James, Becky is saying that we can use mathematics to work out how many bottles we may need for the building and then how much sand will go into it. Is all right? So have you seen all the mathematics that is coming in, James? Yeah. Okay. So now, we're going to look through what is here. The first one, windows without a glass. Can we get any mathematics from that?
No.
Okay. Why?
That's got nothing to do with numbers. It's got nothing to do with numbers.
It's got nothing to do with numbers. Yeah.
You can't make it mathematical because it ain't a question, so how are you meant to work it out?
Okay, well done. So you are all agree that we can use mathematics to work out this. So let's track it off. What about the second one? Could be a link between the bottles.
No, that's just common knowledge.
Okay, let's see. And then the next one, how many bottles do we need? Yeah. Well done. So we're going to choose that. And then the next one, how big is the school?
Yes.
Yes, we can use that. And then how long is it going to take us to finish?
Yeah. Prediction.
That was prediction. Okay, let's see. And if a bottle crack, the house will collapse. Can we use a mathematics for that? No. Okay.
You can. How much weight do you need to crack? Yeah, how much weight would it take to crack a bottle?
Excellent. So it's like now people are saying that we can, which means that they can do it.
So that's science.
Mathematics.
Well, I suppose it's science and maths.
Yeah, mathematics is everything that is around us. So if it can happen in science, then it can happen in mathematics. So if you can do it in science, it means you can also do it here. And then all bottles will melt if there is a strong heat. Okay. And then how much will it cost? Okay. Measurement of the bottle. Yes. Okay. So now we've been able to identify the questions that we can use mathematics to work them out and those that we cannot. So I want everyone here, every group, to choose one question that they're going to answer. So can you now start, please? So what question did you choose? How many bottles do you need? So to start with that, what are the things that comes into your mind?
You have to find out the area of the bottle.
You have to find out the area of the bottle and the room measurement.
What's the measurement?
8 meters, 11.
There you go, 4 centimeters. And I'll measure it like
No, we don't need to measure it that way. We're measuring how long the bottle is, so we can see how many bottles you need to have a whole room. So we're going to measure up the whole room afterwards.
You're saying that you find how much the sand costs. What about if you are in a village where you don't buy a sand?
Then you find sand.
What?
You find sand.
You find sand. So you're talking about the cost. And now your bottles are free. Your sand is also free. What else? So think of what else goes into. Yeah, so can you write all of them and then estimate the price of 1 bag of cement and then start from there?
Why don't you say 8 meters?
You have to divide the area of the room by 33 centimeters to find out how many bottles you need.
Corners can't be worked like that because you'd need the cement in between. So they've decided as a quicker way, they stack the corners like towers, so it saves them time, and they can get it all done in different parts. So they start with the bottles, fill them up with sand, make the walls and all that, and then put the plaster on them. Well, these are the measurements of the bottles. That is how long the wall is. Yeah, and we had to divide it by 4 corners, which means we're going to need 7,480 bottles to fill a corner. We found the measurement of 1 bottle, and we are 34 centimeters, and then we find the measurement of the width and the length of the room, which is 7 times 8 meters. Then we're trying to find how many bottles we need in 1 room. Because it's in meters, isn't it, right? So you have to do like 800 times 700. Divide it, centimeters. Divide it by 33, and then you get just under 17,000.
Now each group is going to tell us what they've done and then why are they doing that. Ali, what was your problem and then how did you solve it?
We don't know how many bottles do we need
for
the class. We measured that, it was 8 meters, and we measured this side, which was 7, and we needed 80 bottles there and 70 bottles here. So we done 80 bottles and 80 bottles, that makes 160, and we done 70 and 70, which is 140, and altogether we need 300 bottles. Then we measured the ceiling. It was 2 meters 90 centimeters, and we measured the bottle 35 centimeters.
And how many bottles were?
80 bottles.
How did you know that?
I think the bottles wide were like 10 centimeters.
It's 10 centimeters.
Yeah.
So measuring this side, which is 10 centimeters, is called what in mathematics?
Diameter.
Diameter. So you measured your diameter, and then when you got 10 centimeters, what did you do?
thing, we see how many do we need in 8 meters, and it was 80.
Yeah, so how did you work that out?
Like
10
10
times
times 8.
So you did 10 times 80 and you saw that it's 800.
Yeah.
Okay, well done. Then let's move on to Jack and Macaulay.
Our problem was how to do the corners work.
Yeah.
And as we saw in the pictures, they
Yeah.
use towers.
Yeah,
And we've looked at 2 ways we can build a tower. One, stacking the bottles up.
yeah,
All it takes is a strong wind to blow it up.
Yeah.
So the corner could collapse,
Yeah.
probably taking the wall with it. But if you use like towers, which would probably take more bottles, but you have to fill in the gaps with like plaster or cement. So
Yeah.
if you have a stronger wind, it won't really knock over.
okay.
Our problem was we needed to know how many bottles it would take to make one wall. So we measured top to bottom and we times it to get the area of the wall. Then we got the bottle and we got one side of the bottle, which is the base, and we got the area of that. And we wanted to measure and then we divided it by the thing so to get the answer to how many bottles it would take to fill up a bottle.
Okay.
But I think the answer we couldn't get it because the measure strip was 10. It said 10 feet, but the thing was meters. So we don't know. I think we have to convert it first.
The question that I want to ask is, always the things that happen around us, do you always think of it as mathematics as we've done today? No. Okay, so from now on, this is what you have to be start thinking. Everything that happens around us has got mathematics in it. Do you want us to continue doing mathematics in this form or not?
Yeah.
Is it interesting?